Okay, mitochondrial ATP production. For the cell, glycolysis yields an immediate net gain of 2 ATP molecules for each glucose molecule that it breaks down. However, a great deal of additional energy is still stored in the chemical bonds of pyruvate. The cell's ability to capture that energy depends on the availability of oxygen. The cell's ability to capture the energy depends on the blah, blah, blah. If oxygen supplies are adequate or sufficient, mitochondria absorbs the pyruvate molecules and breaks them down. As you will see in the next section, the hydrogen atoms of each pyruvate molecule are removed by coenzymes and are ultimately the source of most of the cell's energy gain. The carbon and oxygen atoms are removed and released as carbon dioxide in a process called decarboxylation. Recall that a double membrane surrounds each mitochondrion. The outer membrane of mitochondria contains large pores that are permeable to ions and small organic molecules such as pyruvate. Ions and molecules easily enter the intermembrane space, separating the outer membrane from the inner membrane. The inner membrane contains a carrier protein that moves pyruvate into the mitochondrial matrix, where it's broken down through the citric acid cycle. Yes. So in the mitochondrion, pyruvate molecules participates in a complex reaction involving NAD and another coenzyme called coenzyme A, or CoA. This reaction yields one molecule of carbon dioxide, one of NADH, and one of acetyl CoA.